If an electron collides with a positron, they would annihilate each other and can create gamma-ray photons. This is called pair annihilation. In pair annihilation, the mass energy is conserved. Before the annihilation, the electron and positron's kinetic energy plus their E equals to mc squared turns into the energy of the photons produced. Because of pair annihilation and the fact that there are a lot of electrons in nature, positrons usually do not survive very long before getting annihilated. Now let's try this problem. An electron and a positron traveling at the same speed of 5,000 meters per second, but in opposite directions, collide with each other and produce two identical gamma-ray photons. Find the photon energy of each of those two photons. Again, we will use mass energy conservation. Before the collision, the electron and the positron, they both have 1/2 mv squared. So we have 1/2 m times the v squared. And because they have the same mass and the same speed, so we just have to multiply this by 2 to take care of the kinetic energy for both particles. And then we also have the 2 mc squared of the electron, because again, they have the same mc squared. And afterwards, we would have two identical photons, so that's 2 times the hf. Now this is the same mass, and this speed over here is 5,000 meters per second, and the c is 3 times 10 to the 8th meters per second, which means the speed v is much less than the c. And then if we square them, it'll be even smaller than the c squared, which means that this term is going to be much smaller than that term. So I'm just going to ignore it. And so we have twice the mc squared. The mass of the electron is 0.511, and that's mega eV over c squared. And then I have to multiply this by the c squared, so the c squared cancel again. And this will equal to the twice the hf. And because this is 2 times 0.511 mega EVs, that equals to twice the hf. That means the energy of one photon, hf, would equal to 0.511 mega EVs. So that's the answer.